Most people think gold-rich rivers are rare accidents. A lucky location, a random discovery, a place where treasure somehow ended up by chance. But rivers full of gold are almost never random. Because before gold ever reaches a river, the earth spends millions of years creating the conditions for it. And once you understand those conditions, rivers stop looking like simple flowing water. They become moving geological systems. Every canyon, every exposed bedrock wall, every sharp bend and narrow channel begins revealing clues about hidden mineral history beneath the landscape. By the end of this, you're going to understand why certain rivers become naturally rich in gold, how geology controls where gold enters river systems, and why experienced prospectors study mountains and rock structures long before they ever search the water itself. Because gold-rich rivers begin far upstream, long before the river even forms. At first glance, a river appears simple, water flowing downhill through rock and sediment. But rivers are actually part of a much larger geological story, a story connected to tectonic pressure, hydrothermal systems, erosion, and the slow destruction of ancient mineral deposits buried deep underground. And this story begins beneath the Earth's surface. Deep underground, heat and pressure constantly reshape the crust. Fault systems fracture rock layers. Hydrothermal fluids rise through structural pathways. Minerals dissolve, move, and eventually crystallize inside fractures. Quartz veins form, sulfide minerals develop, and under the right conditions, gold becomes trapped inside these underground systems. But these deposits rarely stay buried forever. Over immense periods of time, the Earth begins exposing them. Mountains rise upward through tectonic uplift. Rain, temperature changes, and erosion slowly break rock apart. Ancient quartz veins begin weathering at the surface, and tiny particles of gold escape into surrounding landscapes. This is where rivers enter the story, because rivers become natural transport systems for everything erosion releases. Sediment, gravel, quartz fragments, heavy minerals, including gold. But here's the critical part most people never realize. Rivers do not distribute gold evenly. They concentrate it, and they do this through physics. Gold is extremely dense compared to ordinary sediment, which means moving water affects it differently. Lighter material travels farther and faster. Sand moves easily downstream. Organic debris drifts with the current, but gold resists movement. And because of that resistance, rivers naturally begin sorting it into specific locations. This is exactly why some rivers become rich in placer gold, while others contain almost none at all, because the river itself is only one part of the system. The surrounding geology determines whether gold enters the river in the first place. A river cutting through barren terrain may carry huge amounts of sediment, but almost no gold. But a river flowing through ancient hydrothermal zones, mineralized fault systems, quartz-rich mountains, or greenstone belts becomes entirely different. Now the river is connected to gold-bearing geology, and once erosion begins feeding material into the drainage system, the river slowly starts concentrating heavy minerals over thousands of years. This is why gold-rich rivers often exist near very specific geological environments. Ancient mountain belts, hydrothermal quartz systems, fault-controlled mineral zones, eroded volcanic terrains, regions shaped by deep tectonic activity millions of years ago. Because these landscapes once created the gold before rivers ever moved it. Now here's where the process becomes fascinating. Water flow itself controls where the gold eventually settles. As rivers move downhill, current velocity constantly changes. Narrow channels speed water up. Wide sections slow it down. Obstacles create pressure drops and turbulence. And whenever water suddenly loses energy, heavier materials begin settling first, including gold. This creates natural concentration zones, inside bends, behind boulders, bedrock cracks, natural riffles, waterfall bases, ancient flood channels. Each location becomes a trap where heavy material quietly accumulates over time. And this is why experienced prospectors study river behavior so carefully. Because gold follows hydraulic patterns, not random chance. But perhaps the most important part of river gold discovery is bedrock. Many beginners focus only on loose gravel and surface sediment. Experienced prospectors often focus on what lies underneath, because exposed bedrock acts like a natural gold trap. Cracks, fractures, crevices, and rough surfaces create low-pressure zones where dense particles settle and remain protected from strong water flow. Over years, decades, even centuries, gold can accumulate inside these hidden spaces while lighter material washes away. And sometimes the richest concentrations remain invisible from the surface. Now imagine a river cutting directly through old mineralized mountain rock. Every flood event slowly breaks apart quartz veins upstream. Tiny gold particles enter the drainage system. The river carries them downward. And over immense periods of time, hydraulic sorting begins concentrating that gold into specific locations. This is how rivers quietly become gold-rich. Not instantly, not magically, but through continuous geological processes operating over thousands and sometimes millions of years. And once you understand this, the landscape changes completely. A canyon becomes evidence of erosion history. Quartz fragments in river gravel become clues pointing upstream toward older mineral systems. Black sand deposits reveal areas where heavy minerals concentrate. Even the shape of the river itself starts revealing where dense material may settle. Suddenly, rivers stop looking random. They become geological maps written in motion. But perhaps the strangest part is this. Many gold-rich rivers do not look impressive at all. Some appear dry for much of the year. Others flow quietly through ordinary-looking terrain. Because gold does not care about beauty, it follows geology. And geology often hides its most valuable systems beneath landscapes most people completely ignore. This is why professional prospectors think differently. They don't simply search water. They study terrain, structures, rock relationships, erosion pathways, hydraulic behavior. Because understanding the system matters far more than chasing visible shine. And once you understand how rivers collect gold, another question naturally appears. If rivers can reveal hidden mineral systems through erosion and sediment movement, then what happens in environments where water barely exists at all? What happens in deserts, where ancient bedrock lies exposed directly at the surface, where erosion strips landscapes bare, and where hidden gold systems remain preserved in silence for thousands of years? That's exactly what we're exploring in the next video. Because in the next episode, we're going to uncover how experienced prospectors read dry desert landscapes to identify hidden gold systems long before gold is ever seen. Most people walk across deserts thinking they are empty. But deserts are not empty, they are exposed. They strip the earth down to its memory. And when you understand what the ground is quietly revealing, you realize something remarkable. Gold, silver, and platinum do not hide randomly. They follow symmetry. They leave patterns. And deserts, more than any other landscape on Earth, reveal those patterns clearly, if you know where to look. Gold, silver, and platinum are often treated as separate metals, born from different worlds, valued for different reasons. But beneath the surface, they are connected by the same geological forces: pressure, heat, fluid movement, and time. In deserts, those forces are no longer buried beneath vegetation, soil, or water. They are written directly into stone. Dry climates preserve geological truth. Rain does not wash it away. Plants do not cover it. Erosion works slowly, honestly. And this is why some of the world's richest precious metal discoveries were not made in forests or valleys, but in places that looked lifeless. Gold forms when hydrothermal fluids move through fractured rock deep underground. Those fluids carry dissolved metals, rising slowly until pressure drops and the metals are forced out of solution. Gold settles first, heavy and stubborn, locking itself into quartz veins, shear zones, and fault lines. Silver often travels with it, but farther. Silver remains mobile longer, spreading outward into surrounding rock, staining the earth subtly. In desert terrain, this silver does not rot away. It oxidizes. It turns stone faintly gray, green, sometimes blue-black. Not bright, not obvious, but consistent. Platinum forms even deeper. It originates in ultramafic rocks, ancient magma bodies that cool slowly beneath the crust. Over millions of years, tectonic movement pushes fragments of these rocks upward. Deserts expose them. Dark, dense stones, heavy underfoot, often ignored. Yet these rocks tell the same story: extreme pressure, ancient origin, and metal concentration that cannot be recreated. In deserts, the absence of soil becomes an advantage. You can see fault lines clearly, long, straight scars cutting through rock. These fractures are not random. They are pathways. Gold loves pathways. Silver follows them outward. Platinum hides near their roots. Quartz becomes a language here. White quartz veins cutting through darker host rock are not decoration. They are evidence, especially when the quartz is fractured, iron-stained, or broken. Rust colors are not decay. They are oxidation halos, the ghost of metal that once moved through that stone. Desert quartz often looks ugly, cloudy, broken. Veins that seem worthless. Those are the dangerous ones, because perfect quartz rarely carries value. Broken quartz means movement. Movement means opportunity. Silver announces itself differently. In deserts, silver often appears where rock looks slightly wrong. Darkened patches, greenish tints, stones that feel lighter than expected. Silver minerals oxidize near the surface, and the desert preserves those oxidized skins like fingerprints. Platinum is quieter. It does not stain brightly. It does not sparkle. It hides in heaviness, in rocks that feel denser than they should be, in black sands left behind after wind removes everything lighter. Desert washes, dry riverbeds, are critical here. Even without water, gravity still sorts material. Heavier metals sink. Over time, wind replaces water. The same physics apply. Platinum, gold, and sometimes silver collect in subtle traps, behind rocks, in bends and depressions, where motion slows. This is symmetry in motion. Gold settles closest. Platinum settles deeper. Silver spreads wider. Different behaviors, same rules. One of the strongest desert indicators is repetition. One strange rock means nothing, but a pattern means everything. Quartz appearing again and again. Rust colors repeating along a line. Dark, heavy stones clustered unnaturally. Nature repeats what works. Deserts allow you to see repetition without distraction. And this is why modern prospectors often fail. They search for shine instead of structure. They chase surface glitter. They ignore geometry. But geometry never lies. Straight lines in nature are rare. When you see them, they matter. Faults, veins, contacts between rock types, boundaries where pressure once changed. Gold respects boundaries. Silver leaks across them. Platinum anchors below them. In deserts, these boundaries are exposed like pages torn from the Earth's diary. Even color matters. Reddish-brown rock indicates iron oxidation, often associated with hydrothermal activity. Pale, bleached zones suggest chemical alteration. Greenish stains may hint at copper, which often travels alongside silver and gold. None of these signs guarantee metal, but together they speak. Deserts do not whisper loudly, but they never lie. And here is the symmetry most people miss. Where you find gold indicators, silver is rarely far. Where silver spreads wide, platinum often lies deeper nearby. Different depths, different expressions, same origin story. This is why some desert regions produce all three metals over time. Not at once, not obviously, but inevitably. The Earth does not waste effort. When conditions are right for one, they are often right for all. Deserts did not always look this way. What appears dry, lifeless, and still today was once shaped by water, pressure, and motion on a massive scale. Long before sand dominated the surface, rivers carved through rock, oceans advanced and retreated, and mineral-rich fluids moved freely beneath the crust. This matters because gold, silver, and platinum are not just products of heat and pressure, they are also products of movement. In many desert regions, ancient river systems once carried enormous energy. When climate shifted and water vanished, those rivers didn't disappear completely. Their paths hardened into stone, their beds became dry washes, their curves became silent traps. And heavy metals never forget gravity. Gold, silver, and platinum responded to those ancient flows exactly the way physics demands. Gold dropped first, heavy and decisive. Platinum followed, denser still, sinking deeper into natural depressions. Silver traveled farther, lighter and more willing to scatter, coating surfaces and seeping into fractures. Today, deserts expose these systems without disguise. Dry washes, arroyos, and paleochannels, ancient river paths now frozen in place, are among the most honest geological storytellers on Earth. They reveal sorting, they reveal concentration, they reveal symmetry. When you examine a desert wash closely, the clues are subtle but consistent. Heavier material concentrates on the inside bends. Black sands gather where motion once slowed. Angular quartz fragments indicate proximity to source rock, while rounded stones suggest long travel. Platinum often hides here, not visibly but physically. It resists weathering. It survives where lighter minerals are carried away. Gold behaves similarly, though it often lodges slightly upstream, caught in cracks and natural riffles formed millions of years ago. Silver, meanwhile, leaves its presence in the walls. Oxidized silver minerals stain surrounding rock. Faint grays, dull greens, sometimes barely perceptible unless the light hits just right. In desert sun, those hints are not washed away. They remain preserved, waiting. This is why desert prospecting rewards patience over excitement. Shiny distractions fade quickly here. Structure endures. Another critical factor deserts reveal is contact zones, the boundaries where different rock types meet. These are not just geological curiosities. They are stress points, pressure changes, chemical reactions. Gold and silver love these boundaries. Platinum respects them. When magma intrudes into surrounding rock and cools, it creates a chemical conversation between host rock and intrusion. Metals precipitate along these borders, especially where fractures allow fluids to move repeatedly. In desert terrain, contact zones are exposed cleanly. You can often walk them, see the color change underfoot, feel the density shift, hear the sound difference when stone strikes stone. This is not romantic language. This is physical reality. Rocks formed under different conditions respond differently to erosion. Deserts strip away the softer layers and leave the harder truth behind. Ultramafic rocks, dark, dense, magnesium-rich, are especially important for platinum. They weather slowly. They stand out. They feel wrong in the hand, heavier than expected, colder, resistant. These rocks are rarely appreciated by casual observers. They lack shine, they lack beauty, they lack obvious reward. Yet they are among the oldest materials on the surface. Time favors density. Gold's relationship with deserts is equally revealing. Because deserts do not replenish sediment quickly, placer deposits remain stable for extraordinary lengths of time. Gold that settled millions of years ago may still sit within inches of where it first stopped moving. This is why deserts can hold wealth that appears untouched, not because it was ignored, but because it was never visible to those who didn't understand the signs. Silver behaves differently over long desert timelines. Because silver oxidizes readily, it often forms secondary minerals near the surface. These minerals can leach, redeposit, and stain surrounding rock repeatedly over thousands of years. Deserts preserve these cycles like layers in a book. One stain means little, repeated alteration means history, and history is where symmetry becomes undeniable. Gold, silver, and platinum respond to the same stress events: tectonic shifts, magmatic intrusions, erosion cycles, climate transitions. They separate by behavior, but they reunite by cause. This is why regions known for gold often later reveal silver. Why silver districts sometimes surprise with platinum. Why the Earth rarely offers one without hinting at the others. Symmetry does not mean equality. It means alignment. Even wind plays a role here. In deserts, wind acts as a sorting mechanism, slowly removing lighter material and leaving heavy components behind. Over centuries, this creates lag deposits, concentrations of dense minerals at the surface. Gold can appear this way, platinum even more so. Silver's contribution is subtler, but it often marks the zones feeding these concentrations. These processes are quiet. They do not announce themselves, but they never stop. This is why understanding geology restores patience. You stop chasing excitement. You stop expecting instant reward. You begin to read, and reading the land changes how you think. Not just about metals, but about value itself. Gold, silver, and platinum are valuable because they obey rules that human systems cannot break. Scarcity, density, irreplaceability. Time. They do not respond to trends, they respond to physics. Deserts teach this lesson better than anywhere else. Nothing is hidden behind excess. Nothing is softened by growth. Nothing is disguised by comfort. What remains is structure, and structure is where truth lives. As we step back and look at the symmetry between these metals, how they form, where they settle, how they reveal themselves, we see something deeper than geology. We see consistency in a world that pretends to be chaotic. Gold anchors value, silver spreads function, platinum enforces necessity. Different roles, same foundation. This is why civilizations return to them again and again. Why modern systems still depend on them. Why deserts, silent, patient, exposed, continue to hold answers most people overlook. And this brings us to the truth most never hear. The Earth does not hide wealth to be cruel. It hides it to be selective. Only those who slow down, observe patterns, and respect structure are rewarded with understanding. Not excitement, understanding. Because when you recognize the symmetry between gold, silver, and platinum, you stop asking what is valuable. You start asking what is inevitable. And inevitability, whether in geology or in human systems, has always been the most reliable signal of all. This is not about finding metal. It is about learning how the Earth thinks. And once you understand that, deserts are no longer empty places. They are open books, written in stone, patiently waiting for those who know how to read.